Griffith's chapter 6, let's talk about the H field. So the first thing that we have is, imagine that we have some material, it has dipole moments in there. Those dipole moments can contribute to the magnetic field. And we have this vector potential due to a single dipole moment that we can calculate. We can define the magnetization as the dipole moment per unit volume. That's important. Capital M, not lowercase m. Now, imagine that I have some material with little bitty currents rotating around in it. We can separate that into three kinds of currents, really. We have bound currents that are just little loops in there. We have free currents that are flowing through the material. And then those bound currents can actually contribute to a surface current, a bound surface current density. If you do a little bit of math, you can show that the curl of the magnetization is the bound current density. And the magnetization dotted with the unit vector in hat pointing away from the surface is the bound surface current density. Those matter. Now, going back to Ampere's law, we have Ampere's law says that the curl of the magnetic field is the total current density divided by mu naught. Well, if I replace the current density with the free plus the bound, I can break it into two pieces. And then I take the bound current density and I replace that with the curl of the magnetization. Then I can move this term to the other side. I can divide by mu naught, and I get the curl of B over mu naught minus the magnetization is the free current density. Now I just take that and say, that's going to be the H field. It's a lot like the electric displacement field, but this for magnetic fields. And then I have a new version of Ampere's law that says that the curl of H is the free current. We don't have to worry about the bound current now. We get H independent of the free current, and that's what to choose for. Then you can go back and find the magnetic field inside a material once you know properties of the material itself. I know it's complicated, but I know you got this too.